Hello and welcome to a special episode of Science and Curiosity. Normally broadcasting live from the Pensacola studio of the New Covenant Group, but today we have something even more special. We are broadcasting live from a secret, undisclosed location at some place probably in Florida, but I'm not really going to tell you. So, what do we have for today? Well, today, first off, is the 2nd of February. That means that we're already a month into the new year. I can't believe it. I don't know what happened in January. I think somebody stole it. There's been a lot going on, though, in the last couple of weeks since I had an opportunity to just talk by myself and ramble like I always do. One of the neatest things to me right now is the probe Rosetta. That's the ESA probe, or European Space Agency, has come back online after a 2-year hibernation. It's been in space. It was originally launched in 2004, at which point, and in 2011, after doing a flyby of 2 asteroids and then Mars, it went into hibernation. Now, it just came out of the hibernation back on the 29th of January, and at which point it came back fully operational. That was something they're worried about. We don't usually have probes that go into hibernation quite that long. We'll be having the Messenger probe that's approaching Mercury here shortly. But this is a really kind of a big trial launch. I mean, you have the probe itself. The plan is it is going to intercept a comet. This is the Churyumov, Russian name that I can't pronounce, comet. It is going to intercept the probe, or intercept the comet, and attempt to go into orbit around the comet itself. And at that point, Rosetta is going to launch a lander. The lander's name is Philia. It is going to land on the comet itself for taking samples. Now, to give you an idea, the comet itself is it has a 6.5-year orbit roughly around the sun. It's smaller than Halley's Comet, the famous comet that comes around once every 70, 80 years. And Halley's Comet has a diameter about 15 by 8 kilometers. This comet, G7P, or the Churyumov, I'm going to try this, Gero-Simonenko. If I'm close, great. If not, I'm American, I can get away with it. It is about 4 kilometers all around, so it's much smaller than the actual probe, or than Halley's Comet, the famous comet that we most commonly think of. Now, the comet itself has, like I said, about a 6.5-year orbit. When the probe is due to intercept it, it'll be at its closest approach to the sun, or the perihelion. And the idea is that at this point, they'll be able to bring the probe in, it'll rotate, or it'll go into orbit around the comet, and at that point be able to launch the probe, the Philia probe. And that'll be the first time we'll have done something like that. And by we, I mean the space agency, planet Earth, really. This is a ESA mission. It's not tied to NASA. Now, NASA did have a similar program. Maybe people remember some years back, the Stardust program, which was a similar program to study the comet Wild 2, and actually was able to retrieve samples of the comet's coma, or what we see as the tail of the comet here on Earth. That probe was launched in 1999, and then it returned with samples from the tail of the comet in the early 2000s. So the idea here is that we're going to actually, or say we, ESA, the European Space Agency, is going to be landing the probe on the comet, taking samples, doing normal lander work like what we see with the Mars landers, and returning data. This will be the first time something like this has been attempted. All that Stardust did was basically catch up with the comet, capture particles that were coming off the comet in gels that were embedded in a panel on the probe that was then on Earth. So this would be just incredible engineering physics to catch this orbit. Now, also in space, Stephen Hawking recently had a big announcement that really kind of got captured by a number of news agencies, including Nature News, not Natural News. It's not a science. Nature News is the news publication for the journal Nature, the large science journal. And they all kind of ran with the headline, Stephen Hawking states that black holes do not exist. Now, that's actually not true. Not exactly. What he's saying is that as we've defined them previously, black holes do not exist. What we're looking at is there is now there's been an issue for a long time with black holes. Now, black holes, to kind of back up here, maybe you don't know, black holes are the end result of very massive stars. Now, these stars end up being so massive that at the end of their life, they end up collapsing down on each other, and gravity starts compressing them more and more. As that happens, all the mass of that star is compressed into a continuously shrinking point until it comes to a point of singularity where it's extremely small, extremely dense, and at that point this becomes what we call a black hole. Now, classically, what we'd be saying is that this black hole being so dense, being so compact, and so the gravity around it was so warped that things would not be able to exit the black hole. So you'd have the light being unable to escape. You'd have, and that's why they were called black holes, because you aren't able to see them. There's nothing there. They're just, the light is fully absorbed into the black hole. Any matter that gets too close to the black hole is sucked in, and it's just, as far as we knew, it was just kept there. Now, Stephen Hawking came up with a theory that described what's called Hawking radiation, where over time the black hole eventually basically evaporates as information is released. But it's not, it's radiation, it's not matter being released. But what he's talking about here, and I'm going to have to say, this is so far outside of my ability to understand. Like, that's normally the case. When I'm talking, I'm usually outside of my knowledge level by a great distance anyway. In this case, even more so. This deals with physics, quantum physics, relativity, and just a number of things. So I'm going to try to explain it as best as I can from what I've been able to read. And it seems like from what he's saying is that black holes still exist. Now, what we recognize as black holes still exist. What's changed is how we are defining them, and that description of a black hole is what is different now. So he is saying that the black hole, this event horizon, this area from where when matter enters, it is unable to escape. That event horizon doesn't exist in the idea that we thought that it did. What is instead is what's called, what he's taken to calling an apparent horizon. Now, the apparent horizon would be where the gravity is so warped, the matter physics is so warped in that area, that when light tries to escape from the black hole, it's more or less held in place. And this is kind of in the same way as the light is trying to escape, but it's being held in place by gravity, but not just stopped, not just held there, but the example he was giving to try to explain it to people like me is that it's stuck on a conveyor belt. The light is trying to move forward, but space is warping in at the same time. So it's held in place that way. It's trying to escape and it's still moving, but space is warped around it and it's just unable to leave that area. This is to try to better handle an issue that came out of trying to understand black holes through quantum physics, which reported that it should be basically infinitely hot as you approach. Now, one of the other issues is something called spaghettification, where as you get closer, the gravity is such that you're actually pulled and are stretched out. The gravity at your feet is stronger than the gravity at your head. It actually pulls and stretches out the matter that makes you up until you're essentially destroyed. Now, that still does seem to be the case in the sense of spaghettification, but that event horizon no longer seems to be there. Instead, you have this apparent horizon. And the important part here, the really important part from this new description he has, is that it would allow for the collapse of this apparent horizon and the matter that's been absorbed by the black hole to eventually be released back into space. Now, that means that, classically, we thought that the black hole would evaporate eventually, that it wouldn't be that the information was basically lost. You end up with this radiation that no longer matches the information that originally came in the form of the matter that was absorbed. But here, what we're seeing is that matter is going to be released. Now, it's extremely damaged and does not in any way resemble its original form, but that matter is then released back into the universe. And that was something that people really didn't, for the longest time, we had a much different concept of black holes, that they absorbed all this, and so we would no longer, that information, that matter and all was just completely lost. So this is a much different interpretation. But black holes, as we have always, black holes, the mass that we observe, still exists. Now you might ask, how are we able to observe them if we can't see them, if light's unable to escape? And that's a good question. What happens in a black hole is there's two ways that I'm aware of that we really are able to observe them. One is my favorite, and I've used this term before, is microlensing. The gravity is so powerful around a black hole due to its immense density that the space is warped around the black hole. And when it passes in front of another object, like another star or another galaxy, it warps that light that is passing around it. It focuses it, which is why it's called lensing. And we can actually see that as it moves across the background. In fact, that's how they recently discovered a black hole that was actually very close within our galactic neighborhood not that long ago, and a very young black hole at that. The other method is one of the more common star formations we see out in our galaxy and probably in other galaxies is paired stars. You have two stars that orbit each other, like that one they found recently with the exoplanet that's been called Tatooine, because it's a planet that orbits the two distant stars. So what can happen is one of those stars can turn into a black hole, and you can actually see the mass and the matter being sucked off of the companion star into the black hole. And by that way, we can also see the black hole. And I'm sorry, there is one other method where the black hole itself, what we've been calling the event horizon, it has a debris field basically around the hole itself. That's, if you watch a lot of sci-fi, you'll see this vortex often, is how it's presented, of matter around the black hole. And while the black hole itself doesn't emit any kind of frequency or radiation, that debris field around it can. And we can see, or we can detect the radiation, the heat that comes off of this, and that actually will inform us. And that's one way of detecting them as well. That's the three ways I can think of it, I remember at the moment. And again, I want to just say that this is kind of really far out of my information level, my understanding level. So I'm probably completely wrong on how I'm presenting his new description of black holes. So do go to, I'm going to share this link on my Facebook page. It'll be shared on the page 4, Science and Curiosity. Make sure you check that out. Read it yourself. You might be able to, and probably will be able to get a better understanding of what he's saying here. Now, one of the things that's important to understand too is, unlike some other studies, in this case, this is not yet past peer review. This is just a paper he submitted. So this is something too where we've got to remember that just because Stephen Hawking is very famous, very well known, does have a substantial body of work associated with him, until it passes peer review, until other physicists have had a chance to examine it and really kind of critique his work, which is actually already going on, but until they have the chance, it's kind of best to hold off and see whether or not this is going to be taken seriously, to see if this is actually a real, that his new description is actually a satisfactory and superior description to black holes than what we've had previously. Because that's one of the issues is that it can't just be that you're making a new theory that sounds good, that looks good. It has to better explain your observations and match the already known science better than the theory it's replacing. And that's what we have to see here with this new idea on black holes from Hawking. It doesn't matter how famous he is, how popular he is, or how successful he's been in other cases. It does kind of lead, it does lead support to his opinion in the sense that he's been right before, but until it's actually past peer review, until people have had the chance to really examine it, we can't really say that that it actually is a better theory in terms of its explanatory power than this previous theory that we've had in terms of the classic idea of black holes with its event horizon and everything we associate with them. So that's that was another interesting thing. It came out recently here. And something a little bit more fun, one of the things I found is that if you go to study the animal kingdom, if you go to study animal behavior, and this is going all the way out from space and black holes to immense things to here on Earth to not immensely small things, really, about bird-sized. Studying animal behavior is something that always fascinates me because of how much we end up kind of learning about our own behaviors and how we act. And what's happened with this study, this was done at the University of Illinois. They captured a type of bird. It's called a yellow-breasted chat. They're a type of warbler native to the area, and what they did was they captured them using mist nets. These are those immense, very loose nets that prevent the bird from being injured when it's captured. And then they fitted those 32 birds with a small backpack that would allow them to track the birds as they went about their normal routine. And what they ended up finding is that you have the normal behaviors. They're diurnal, which means that they only are out during the daytime. And during the daytime, these birds were just acting like birds do. They interact with their mates. They were off finding food, doing the normal bird behavior, like we expect. I mean, there's nothing unique there. But after nightfall, after it became dark, things changed a little bit. Now, we're familiar with humans having a nightlife, of course, of going out on the town, having fun. Some people do that. I don't. I just stay home and read. Nothing wrong with that. But what they found with these birds is that these birds they essentially have their own nightclubs. They have their own nightlife. They will go out, and what's really kind of funny is that they will do all the behavior that we normally kind of associate with human behavior, in the sense of we're used to kind of looking at animals and seeing, we usually look at bonobos, and a lot of people will study them for their ways they act as primates, in the sense of we are primates, what actions do we share? And we usually kind of tend to point out the nice behavior, the altruism, the way that they work together as a group that ensures their own survival, and how that is reflected in modern culture in terms of how we interact as groups. This actually is kind of pointing to, I don't want to say bad behavior, but something that is definitely regarded by many people as immoral, in the sense that we are. This is, you have the two birds. These are pair. They pair off. They mate. I didn't see if it said for. It didn't mention for life, and I'm not familiar with this bird species. But they will pair off and they will mate and they build nests and they raise young, just like as they do. But what these birds were doing were at night, one of the partners would fly off, the other partner would fly off. Uh, Due to the way that their nests work, one would be able to run off without the other seeing it, and the male would go to one location, the female would go to another location, and essentially it's a nightclub, like what you see here. It's a party going on with birds. Uh, uh, and these birds would then mate with something that an animal or another bird that's not their partner. They would go off and have wild, crazy bird sex. Uh, and then they'd come back. Now, what you'd see is that you'd end up with females raising eggs that were not their partners, but their partner would end up taking care of them. You'd have the male birds impregnating females that would raise their clutch without them having to actively be involved. This is something that we see in other parts of nature as well. It's called the sneaky male effect, or in this case, sneaky female effect too, where males that are not okay. I'm sorry about that. A little bit of technical difficulties trying to use it from my undisclosed location somewhere in the Atlantic Midwest, possibly. Uh, so what was I talking about? I was talking about wild, crazy bird sex, right? Okay. So these yellow-breasted chats were found to be hooking up with partners that were not their own. They're going out to these nightclubs. These were actually seemed to be designated areas, but where they would go out and would interact with others that were not their partners. They would reproduce with each other, and then go back to their normal behaviors during the day. What's interesting is that bird behavior, or these birds do not have superior eyesight to ours at night. They have just normal eyesight. Uh, that is something that we talk about with human behavior. You see this, we regard it as immoral, improper behavior. Here's something where animals are doing something very similar to what many people do. And I'm not saying that this is proper behavior. Don't get me wrong. I'm not implying that at all. I'm just saying that this is something that is here's something animals are doing that we recognize in human behavior as well. And in this instance, what it's being explained by is the desire of reproduction. The idea that with genes, maybe you've heard of Richard Dawkins, the selfish gene. And in that idea, now he's not talking about animals or behaviors as being selfish. He's talking about the preservation of genes in a population, and those genes will select for their own. The idea is, and this isn't an active way, but genes are trying to protect their own survival. And it's still not a very good explanation. The idea that these genes are trying not to add purpose to it, and I keep running into the same problem. I'm sorry, I didn't. Uh, that came off the cuff. Not very good at that. The what they're doing is they're trying to increase the chances of their genes being passed on to the next generation. One of the ways of securing that is making sure you have a stable family unit, like we will talk about here with humans, but also making sure that your genes are spread out as much as possible. Two, by reproducing with as many females as possible, we'll get the genetics out to the next generation and have more of a presence in that next generation than possibly another male that doesn't go out and reproduce with as many females as possible. So that's something that you do see, is that this is a behavior that's selected for because of infidelity, allowing for more of this genetics being passed on to the next generation. Now, this is one where I'm not, well, it may seem like it, I'm not saying anything about whether this is moral behavior or anything like that. Just something that's interesting, that's observed in humans and in this case birds. We usually look at primates to find similar human or similarities in behavior, but here's something going to birds that reflects something that we see as actually bad behaviors in ourselves. Going just a little bit smaller and much older. So we're looking at this is also older in the sense that this is kind of an older story, but I thought it was really interesting. One of the things to keep in mind first is that that the greatest source of biomass, in other words, where the most amount of living organisms exist, is in the ocean, which makes sense if you remember that life, as far as we know, probably originated in the oceans. Now, specifically, we don't know where, we don't know how exactly yet, we don't know, we may never know because of the conditions, but life seems to have developed in or around the oceans, probably from there, or then from there spread out to land. But because of that being its origin place, life is really almost overrepresented, you could say, in the ocean. All of the biomass or not all of the biomass, I'm sorry, most of the biomass is concentrated in the oceans, which is one of the reasons we should really do a better job of trying to take care of and maintain it. For no other reason than the majority of the oxygen we breathe is produced by the ocean, so maybe it's a good reason to try to not pollute it so much. But what's really interesting about this, now to take another step down the chain there, most of that biomass is not fish, it's not multicellular organisms, it's actually mostly single-cell organisms, living organisms, like plankton and other similar small creatures that are making up most of that biomass. And most of that is not actually free in the ocean itself. It's in the sediment at the bottom of the ocean. So in all that material down at the bottom, that's where you'll find most of the actual biomass, most of those living organisms in the ocean. But what's really cool about this, while doing a study to examine these unicellular organisms, a collection was returned which was actually single-celled organisms that date back to the Jurassic period. The Jurassic period was one of the earlier periods where we had dinosaurs. Now, Jurassic Park was a little off. A lot of those dinosaurs presented in were actually from the Cretaceous, towards the end of the dinosaur era, but this was an era or two earlier than that. And they have been down there essentially since that point. These were life forms that were there, and they were barely able to maintain their own metabolism. They were down there for 86 million years. Remember, the extinction of the dinosaurs occurred at 65 million years. So they've been down there for 26 million years, or I'm sorry, 21 million years before the extinction of the dinosaurs, before mammals had a chance to take over the land, before mammals led up to modern humans. These organisms have been down there from that time, surviving in a very oxygen deprived environment and survived there up to the present day, where they were found by researchers trying to do a study on this the biomass that we find underneath the ocean, the material I was speaking about earlier. So that, to me, is just one of those wild things. We had Dr. Schweitzer on the show a week ago talking about how you had soft material being preserved that was found in dinosaur bones through a very unique process. Here we have where the actual organisms themselves, kept in this very subsistent state, were able to survive that 86 million years to the present day. Now, let's see. These organisms were kind of barely alive. They were very weak. They were not in a environment where they were actually intended to survive. This is something like with extremophiles, if you are familiar with those. Those are life forms that are able to survive in extreme conditions or thrive in extreme conditions. Well, these were prokaryotes, not themselves extremophiles. Something that happens with life forms like this is you can take an extremophile, and some of them can actually survive in space. Now, they're survived. They don't. They are not living successfully in the sense they're not reproducing. They're not able to grow. These were barely able to repair damage. But they were still alive in the sense of their metabolic process was still going. So if you were to look at that and say that is, or if you just have that, that's amazing. If you think about it, you have these life forms that were present at the time of the dinosaurs. This culture was, or these organisms were in existence at the time of the dinosaurs, survived being buried in sediments up to the modern day to be found by modern scientists. That's just, to me, that's just something wild. It is an older study. I didn't see where work had progressed on it. This usually does take time. It doesn't mention in the article that I found anything about their genetics, how different or similar they were to current microbes living. But these were microbes that had been buried 86 million years ago, still preserved in sediment, still alive, not fossilized, due to the nature of the sediments that were found in. And just so interesting to me to have something like that turn up. And finally, one of the things that right now I'm doing something I recommend everybody does. There are a number of online free courses. I'm taking one on, I'm currently working through several on Coursera. One of the things that came up was the idea of philosophy and science. Stephen Hawking, mentioned earlier, declared that philosophy is dead in the sense that it's no longer able to contribute knowledge of the world. Knowledge that science has now taken on that role. Sam Harris is famous for saying that morality can be informed by science, or can be answered by science by itself. This question came up, or this idea came up, that is philosophy at all important? And what I'm finding is that there's two ways that I'm finding it's important for me. And I do think that philosophy is one of those things that does seem to me to be moving away from being its own field. And I'm sure Dr. Shook will take me to task for this, in a sense that it is only going to be useful when you apply it to another field, like the philosophy and biology, philosophy and things that then go back to be applied to the way we handle the things we're learning. Like okay, we can now clone organisms. Then we come into philosophy. Okay, should we clone organisms? Is that something we ought to do? Or if we have the capability of cloning organisms, or just organs by themselves, is that something that should be done just because we have the capability of it? Nuclear weapons is another example of that. We have the capability of using and utilizing, or making and utilizing, nuclear weapons. Is that something we ought to do? And that, to me, is one area where philosophy is important. By thinking about the capabilities we have, we can come to better conclusions. And philosophy, to me, because it is basically thinking about thinking, it gives us it improves our tools on being able to make the right decision. One thing that Dr. Schweitzer mentioned in the previous show is that science is just about collecting data and then maybe applying that data to better understand the world around us. So to go forward from there, philosophy itself now comes into, okay, we have this data, what do we do with it? How do we use it? One of the issues that we had in the 50s was there was data produced by Nazi experiments, torture, done against people that were held in concentration camps. There was a lot of people who did not want that data to be used because of how it was obtained. When it comes to ethics and philosophy, that comes to how do we use it? How do we use it if we do use it? And that's where I'm really interested in learning more about philosophy, and I do see it as having an actual application in science. And the last is just for my own self-understanding. By reading philosophy, by applying myself to the study of it, I begin to better understand myself, my own thought processes, coupled with neurology, of course, the study of the brain. But I also am better able to think. I look at philosophy as well as a way of sharpening your own mind to apply to other things. So in that sense, in that particular way, it's not itself useful by itself, but when you apply it to other things, like we will talk about critical thinking, which is that comes out of philosophy of logic, that itself is applicable to other things. And that, to me, is what's important. All right, we're getting to the end of the show here. Hopefully you can hear me all right. I know there's been some issues with the microphone setup and all that I have here. Realize it's a little awkward at the moment. I'm in a different environment. You go to a new place, you don't sleep well, everything feels a little odd, you go to reach for something and it's not in its proper place. We'll try different, so it's going to be like this for a little bit, and then I'll be back at the studio once the once the events leading to me having to be in a secure location somewhere in Antarctica, not Antarctica, I'm sorry, somewhere mysterious and unexplained, when those events have died down a bit. As always, remember to like the page on Facebook for Science and Curiosity. These stories talked about today will be shared on the page. Especially check out, like I said, Stephen Hawking's release here. Tell me what you think. If you think I'm completely bungled my explanation of black holes, physics, science, Stephen Hawking, that I mispronounced his name, whatever you want to tell me. I probably did all of those. The information about Rosetta will be shared on the page as well. About the yellow-breasted chat and the nightclubs, which I still think is just hilarious. Remember, you can contact me by email. My email is michaelscottfulford@gmail.com. Facebook, Michael Scott Fulford. The Facebook page for the show is Science and Curiosity. And I look forward to seeing you next time.